Good evening, we are Group C and we are going to present our sentiment analysis for the new coronavirus variant, Omicron. Problem identification. Omicron is the latest variant of SARS-CoV-2. It is also a variant that has mutated the most, up to 50 times. It was recently reported the first time in South Africa on November 24th, and now it has spread over the world. That is why some countries have reimposed quarantines and tightened restrictions on social contact to reduce infections. The new Omicron variant and the new restrictions may lead to different sentiments from the people. By performing a sentiment analysis based on tweets, the purpose of this paper is to provide an idea of what feelings Twitter users have about this problem. Data source. The source of data is an external data source from the social network Twitter, where data is in motion, also referred as data in transit. This data is in the process of being transported between two locations and consists of a continuous stream of records, known as streaming data source. Each tweet is composed of several pieces of information in JSON format. This format belongs to a semi-structured data, having information with self-describing structure in more than 2 dimensions. Data ingestion. To extract the data from Twitter, we used one of the most powerful, easy-to-use, and reliable systems known as Apache NiFi to ingest and distribute data. To extract the data from Twitter and storing it in HDFS, the ingestion process has 5 steps with flow file processors involved, which are get and configure get Twitter processor, get evaluate JSON path processor, to get update attribute processors, and get put HDFS processor. After connecting all the processors, Apache NiFi can start to ingest and store all tweets. Data storage. Raw data is stored in JSON format in the raw directory of HDFS. If the data was ingested in different ways, then the directory would change according to the date it was stored. Data will be then restructured with Python, and this time it will store in the standard of HDFS. Standard data will be partitioned for every year and date and will be stored in Parquet format. Data processing. To process the data in this stage, we have applied different techniques and transformations over the data. In this case, we have used Spark, being a multiple processing engine with different libraries to process data in parallel, allowing different data sources with a high computational power. Also, the analysis was divided in 2 steps. The first one, initial analysis, and the second one, sentiment analysis. Initial analysis. In order to understand the data in our data frame, we first print the output of the first row by using a for loop. In second place, after having understood the structure of our data frame, we wanted to determine whether the tweet was an original one or a retweet. As a result, we created a new column using with column that classified each tweet between an original tweet or a retweet. This function checks for each row if the text in column text contains the specific string retweet followed by an @character. In addition, we have created a new table to see the total number of the original tweets and the retweets. To continue with our next step was to determine which hashtags were the most used within our dataset. And with this information, we will plot a word cloud that counts the most used hashtags. To achieve this, we have used a function that selects all the hashtags and groups by themselves and applies the aggregate function count to obtain the number of times each hashtag appears in our data frame in lower cases. For the word cloud, we have used the word cloud library. To be able to use these library functions, the column with all the hashtags had to be converted into a single string that contained each hashtag, being repeated as many times as the count function indicates. Also, a bar chart was plotted using matplotlib.
After having found the most important hashtags in our dataset, we decided to find the most mentioned accounts. To achieve these, we used a function that selects all the Twitter accounts, groups by themselves, and applies the aggregate function count, as we did in the step before, to obtain the number of times each account appears in our data frame. In this next slide, we can better visualize how often was each of the top 10 handles present in our dataset, as we can also visualize in a word cloud the importance of each account. Having the possibility to obtain a large number of tweets with different words and sentences allowed us to do a sentiment analysis in order to identify people's opinions, attitudes, and emotions regarding Omicron from written language. In addition, sentiment analysis nowadays is one of the most active areas of research in natural language processing and text mining. In fact, this research has spread outside of computer science to the social sciences, especially with the growth of social media and social networks. Before running the sentiment analysis, we first cleaned our dataset for the proper implementation of the machine learning sentiment algorithms based on the following rules. Rule number 1, most of the retweets are retweets, so for this reason, we'll remove the RT and the following handle. Rule 2, all Twitter handles must be removed from the text as they do not carry sentiment. Rule 3, all hashtags as well must be removed from the text as they also don't carry sentiment. Rule number 4, all URLs also must be removed. Rule number 5, punctuation does not offer any information, so it will be removed as well. And rule number 6, all words must be lowercase. In order to do the data cleaning, we have used regular expressions to find and replace operations on strings, creating 6 new columns by the different rules already explained and being applied in our data frame. After having cleaned the dataset and with a new data frame with 6 new columns, we applied 2 algorithms known as sentiment intensity analyzers with the use of 2 different libraries, NLTK and Vader Sentiment. The Natural Language Toolkit's machine learning algorithms consist of the most common algorithms in natural language processing, such as tokenizing, part-of-speech tagging, stemming, and named entity recognition. Whereas Vader, or Valence-Aware Dictionary for Sentiment Reasoning, blended a sentiment lexicon approach, as well as grammatical rules and syntactical conventions for expressing sentiment, polarity, and intensity. These 2 algorithms will help us to extract a negative, neutral, and positive score for each tweet. The aforementioned scores are also compounded into a single score, ranging from -1, which means a negative sentiment, to +1, positive sentiment. In order to use sentiment intensity analyzers in the Spark data frame, we have created 2 user-defined functions containing both libraries analyzers and applied these 2 functions to the text lower column, which represents our last transformation. Furthermore, emojis also have a representation of sentiment by the users. We have decided to analyze whether any of our sentiment intensity analyzers actually carry this sentiment into their calculation and to know whether or not we should keep them for the sentiment analysis. Therefore, we created a data frame representing the number of times different emojis were present in the dataset, along with their sentiment and their sentiment scores according to both sentiment intensity analyzers. As we can see, most of the emojis did not carry any sentiment on both of the analyzers, but the Vader Sentiment Analyzer takes into account some of them. Thus, we will leave the emojis in the data frame.
Project results. After having described our analysis, based on our first conclusion about the most mentioned accounts, we can say that the first accounts are related to public figures, such as Ben Shapiro and Martin Lewis. Ben Shapiro is an American conservative political commentator and media host. Martin Lewis is an English financial journalist and broadcaster. For this reason, it makes sense that both have a big audience and being the accounts that have been counted the most in our data set. On the other hand, another interesting outcome is the big majority of accounts related to news as sources, and also the accounts of politicians such as Brit Hunt and the virologist and immunologist Robert Wales. Moreover, in order to understand the sentiment and the attitudes toward our topic of interest, we decided to look at the 3 most counted accounts and their tweets regarding Omicron. Regarding the tweet of Ben Shapiro, we can conclude that his opinion towards Omicron is that the government in the United States and around the world is taking actions without any evidence of the increasing mortality among the variants. For example, from the tweet of Martin Lewis, we can see the different opinions and the polarity among the users, where the majority of them, 39.4%, are in favor with the end of all the restrictions related to COVID-19, while the 29.2% think that COVID-19 restrictions should be stronger. The third most mentioned account The Mercy Tech highlights the importance of the encouragement of everyone to stop spreading the virus and the importance of collective effort by taking actions and measures. In the second slide about the results of our sentiment analysis to better understand the polarity of our dataset, we look first at a histogram with the compound values equal to 0, and then without the compound values equal to 0 for both algorithms, NLTK and Vader. By looking at the first histogram, we can conclude that the majority of the tweets regarding Omicron and Omicron variant in our dataset are neutral because they are around 0. This can be regarding the majority of the tweets in our dataset are facts against opinions based on the news. According to the second graph, it can be concluded that there are very few tweets that have either a strong positive sentiment or a strong negative one. But in the end, we can observe the polarization between opinions which has been prevalent in the last few years regarding political matters. Following this order of ideas, we plotted the same histogram for Verder. Verder with compound value equal to 0 and Verder without compound value equal to 0. Comparing these two graphs with the graphs obtained for NLTK algorithm, we can see that both plots have a similar shape, thus suggesting that the algorithms are not different from each other, even though one takes emojis into account and the other doesn't. After having described the main insights about our first analysis and sentiment analysis with information obtained, we did a new search based on the most mentioned accounts, the total number of emojis being used, and the most popular hashtags, concluding with the following tweet from Dr. Eric Dient. To sum up, this paper highlights the importance of sentiment analysis since it's being applied in almost every business and social domain, because opinions are central to almost all human activities. To achieve our sentiment analysis, we follow the subsequent events. First, data ingestion. Secondly, Jira storage. Thirdly, data processing and data cleaning. Fourthly, initial analysis. Lastly but not least, the sentiment analysis. It's important to be rigorous when cleaning the data before performing the analysis, otherwise our results can be biased. Also, to proceed with the analysis, it's necessary to first ingest a sufficient amount of data, the tweets. Finally, to better understand the outputs, we plotted some graphs, bar charts, and cloudworks. Some other considerations are that the Spark is a multiprocessing engine technology when dealing with big amounts of data and transforming JSON to Parquet files, thus being more efficient. But the main conclusion of this project is that Twitter users have feelings, and all these sentiments can be extracted from the tweets to obtain a general view of how we humans are feeling about one specific topic.